In section 12.3, we're going to start going over circles again. Now, remember that a circle is going to be created when we do a cross-section, a horizontal cross-section of our double cone. Some key things that you need to know when we're talking about circles, and all of this will be reviewed to you if you've already had geometry. Right there at the very center of our circle is the center of the circle. If we draw a line from the center to the edge of the circle, that again is going to be our radius. If we take two radii and put them together, then we end up with a diameter, which is just a straight line that's going from one edge of the circle through the center into the other edge of the circle. Then we have the circle itself. Now the circle is the set of all points that are equidistant from the center. So we know that wherever we are on this circle, we're always the same distance away from the center. Now we've got two equations that we want to use when we're doing circles. And the first is going to be our standard form, or the standard form for the circle. And that's going to be x squared plus y squared equals r squared. Now the reason why we like this one is because if we just have an x squared and a y squared, then we know that the center of our circle is going to be at 0, 0, or the origin. Now the r squared, whatever number that we have occupying this spot right here, opposite from the x squared and the y squared, if we take the square root of that, that's going to give us our radius. So if this number here is 49, we're going to take the square root of 49 and get 7. That tells us that our radius is 7 units, is going to be 7 units long. So if our center is at 0, 0, then all of these points along the circle will be exactly 7 units away from that center. Now our second equation is going to be the general form for a circle. And this is when we bring back h and k. Now what we're going to do is we're going to pair up the h with x, and we're going to pair up the k with y. Now notice that these are both h minus k, or I'm sorry, x minus h and y minus k. What that tells us is that whatever the opposite of k and h are, that's going to end up being our the center of our circle. It's just like when we've done quadratics, absolute value, rational function family, all of that is the exact same thing. We're going to go the opposite of what we see here. So if we had x minus 3, that's going to tell us that our x value for the center of the circle is at 3. If we had y plus 2, then we would go opposite of positive 2 to get negative 2, and that would tell us that the y value of the center is going to be at negative 2. We'll take a look at this in the following problem so you can see how we put this into action. Okay, in problem number 1, we're being asked to write the equation of a circle when we're given its center and its radius. So you can see that the center is going to be negative 4, 3, and the radius is going to be 4. So we need to decide which formula are we going to use. Are we going to use the standard form or the general form? Since the center is not going to be located at the origin, we want to go ahead and use the general form, which again is going to be x minus h squared plus y minus k squared equals r squared. So really all we have to do is take the h value, the k value, and the r value, plug them in, and then simplify it. So we know that the h value is negative 4, so we're going to get x minus negative 4. Now notice that I'm going to go ahead and put that negative 4 into a double set of parentheses there. What this is doing is it's reminding me that I have to multiply the negative times the negative in order to get to the positive. If I leave this as x minus 4, then my equation is not going to be correct. Over here, I'm going to go y minus, and then 3, and then that gets squared, and then we're going to plug in 4 for the radius, and remember that that needs to be squared as well. So come over here and simplify this. We end up with x plus 4 squared plus y minus 3 squared equals 16, and that's going to be our formula, or that's going to be our equation in the general form. For problem number 2, we're given the standard form equation, which is x squared plus y squared, and we're told that r squared is equal to 9. Then we're being told to translate our center 4 units left and 3 units up. So this is actually a relatively easy thing to do. We're going to go back and we're going to change the standard form into general form, which is again going to be x minus. And then since we're translating this 4 units left, 4 units left means negative 4. So we're going to put in a negative 4 right here, and then we're going to close out the second parenthesis and square. Then add y minus, and then over here we're going up 3 units. Up 3 units means add 3. So we're then going to add 3 here, and then square that. The r squared is not going to change any. We're going to keep that at 9. So now what I've got to do is just simplify this. So x minus negative 4, that gives us x plus 4. So x plus 4 squared plus negative times a positive is a negative, so y minus 3 squared equals 9. Now what you're going to notice is this. We know that translating left means negative 4, and translating up means positive, or positive 3 in this case. But you notice here, we went from a negative to a positive, and we went from a positive to a negative. That's the way it always works in general form. Whenever we're dealing with something that starts off as a negative, we always are going to end up with the positive. So the negative 4 becomes positive 4, and the positive 3 becomes negative 3. So really, you don't even have to go through this entire process if you understand that. You could simply just write x plus 4, and then y minus 3, square them both, and then set it equal to your r squared. For problem number 3a, we're given an equation in general form, and we're being asked to find the center and the radius. This is actually really simple here. We're going to find the center by going the opposite of this number. So negative 16, the opposite is 16. And then the opposite of 9, so negative 9. So we know that the center of our circle is at 16, negative 9. To find the radius, all we're going to do is take this number here, take the square root. So square root of 144 is 12. Since the radius can only be positive, we're not going to worry about saying plus or minus 12. It's just positive 12. And that's it for this particular problem. In problem number 3b, we're going to take a look at something that you're probably going to see on the SAT. It might only be one problem, but at least you'll know how to do it now. And it looks a lot more complicated than it is. But what we have to do is we have to go back and we have to dredge up some of the stuff that we did earlier in the year and some stuff that you also did in Algebra 1, and that's completing the square. So what we want to do here is we want to take this equation and we want to figure out what is the center of this circle and also what is the radius of this circle. So the way that we're going to do this is we're going to take anything that looks alike, anything with the same variables, and group them together. So we're going to take x squared plus 8x and we're going to put those together on the left side. Then I'm going to leave a blank space right here, and then I'm going to take the y squared and the negative 10y and group those together. So we're going to have this here, and then then I'm going to leave another blank space, and this is all just equal to 8. So now what I've got to do is I've got to complete the square on both of these. So completing the square, if you remember, is taking an ax squared value and a bx value and finding a c value that would give you a perfect square trinomial. Now the way that we're going to do this is to use the expression b over 2 squared. So b over 2 squared for this one, we're going to use 8 because 8 is the b value. So we're going to get 8 over 2 and then we're going to square that. So then that brings us to 4 squared, and this number is important right here. We're going to use this again. And that takes us to 16. So we're going to add 16 right there, and we're going to add 16 over here, because remember, whatever you do to one side of the equation, you have to do to the other side of the equation. Now, the y squared minus 10y, we're going to repeat the same process. So we're going to go negative 10 over 2, and we're going to square it. And then negative 10 divided by 2 is negative 5. Right here, the 4 and the 5, these are what become your factors. And then we square the negative 5, and that's going to give us 25. So we're going to add 25 here. And again, whatever we do to one side, do to the other. So now, like I said, the 4 and the negative 5 become our factors. So this right here becomes x plus 4 squared. This number just goes right here. Then we get plus y minus 5 squared, because again, this number here, before we square it, is what becomes our factor. Then we've got to come over here and simplify this. 8 plus 16 is 24, plus 25 gives us 49. So we know we've got a perfect square right there. It's going to make this a lot easier. So now we got this written in our general form. We've got x minus h plus y minus k is equal to 49. So now all we've got to do is we've just got to figure out what is the center and what is the radius. So the center, again, is going to be the opposite of what we see. So since we see a positive 4, that means that the center is going to be at negative 4. Since we see a negative 5, the center is going to be at positive 5. The radius is just going to be the square root of 49, and so that gives us 7. So this equation right here has a center of negative 4, 5, and a radius of 7. And again, the way that you figure this out is to do completing the square. And again, you will most likely see at least one problem like this on the SAT. Okay, for the last problem in this section, we're being asked to graph out of the general form. So we're given x plus 1 squared plus y minus 3 squared equals 25. First thing we're going to look at doing is finding that center. So our center, again, is going to be the opposite of this number, so negative 1, and the opposite of this number, so 3. So we know that our center is going to be at negative 1, 3. So go back 1, and then up 1, 2, 3. Then we know that our radius is going to be the square root of that value. So the radius is going to be 5. Now all we've got to do to graph this is go 5 units up, 5 units down, 5 units right, and 5 units left. So we're going to go 1, 2, 3, 4, 5, put a point there. Go down 1, 2, 3, 4, and 5, put a point there. And then go right 1, 2, 3, 4, 5. And then left 1, 2, 3, 4, and 5. Now that we've got that done, all we've got to do is join all of those points with a circle. And you can see it's not the greatest circle ever, but that's what their graph is going to end up looking like.